All right, so this is the classic cliff problem, right? We have a velocity here, we have a height here, and we're asking for several things. What time does it take to reach the ground? How far from this does it land? Find the components of the velocity at the instant it strikes the ground. So when this hits, boom, it's gonna have a Vx and a Vy. And it wants that. And then finally, it wants the speed, which is going to be the Pythagorean. The speed is going to be the hypotenuse of that triangle. Okay? So, how do I find the time? Well, we kind of did this already. I know that for a two-dimensional motion problem, if we want to know how long it takes to reach the ground, we're using the standard kinematics equation, right, which is sort of like delta y is equal to vyt plus 1/2 at squared. Yes? Vy vertically is 0. Okay? The delta y we know to be 78 point whatever, and we know a to be whatever, negative g. So this delta y is negative, this a is negative, and that's going to cancel and take care of that. So we get t is equal to the square root of 2 delta y over a. Right? Delta y was what, 78 point something?
Yeah, 78.4.
78.4, so that gives me 157. So that's 157 divided by 10 is like 16 squared, so it's around 4 seconds. So what is it exactly? Or
Like 4, a little bit.
oh, exactly. Okay. All right, 4 seconds. Good. That's good enough. All right. So that's the first part. 4 seconds. What did it want next? 4. So now, if I'm trying to find the horizontal distance, I use my second. See, this is my first kinematics equation, and my second is delta x is equal to vxt. Vx was what, like, wasn't it 1,200 meters per second?
1200, yes.
So 1,200 meters per second times 4 seconds gives us 4,800 meters. So what they're asking for is when this thing falls and hits the ground, does it make sense to you that it has a velocity that looks like that? So if I zoom, no, okay, I'm not going to zoom, never mind. I was going to zoom, and it said no. So, okay. Had I been able to zoom, you would see that this vector is made up of two things, Vx and Vy. Does that make sense? Right? The Vx is 1,200 meters per second. It never changes, because what is the acceleration horizontally? What is the acceleration horizontally? 0. Because we are neglecting air resistance on all these problems. So there's no acceleration horizontally. Vertically now, I don't know the final velocity. We know, so if we want to find this, we know initially the vertical velocity was 0 meters per second, right? Does that make sense? We know several things. We know that at time it fell for 4 seconds. We also know that the acceleration was gravity. So for my sake, if I just say 10 meters per second squared, then V final y, or just Vy as the case may be, okay, is going to be equal to V0y plus AT, which is equal to 40 meters per second. So those are our two components. 40 meters per second. 1,200 meters per second and 40 meters per second. Now the last question says, what is the speed? The speed is the magnitude of that final vector, right? This is VR, the resultant. This was Vx, this was Vy. They want to know this, the absolute value of that. So they just want to know the size of that, not the direction. How would we find this angle, this direction? What two sides do we know? right? So use inverse tangent if we wanted to, but they didn't ask for that, so that's fine. So we're just gonna get VR is equal to the square root of Vx squared plus Vy squared. And Vy squared is like, what, 1600, Vx squared is some giant number, it's gonna be around 1200. What's the final answer? 1200 and, well, when you take the square root, what is VR?
Should be close to 1200.
Yeah, it's very good, because the 40 is very small compared to 1200.
Like 1200.6.
Oh, okay, so we'll just say 1200 then. Okay, and do you see why that is? Because if I actually draw that last scale, it looks like this. Right, like a really, really tiny vertical component. Right, the horizontal component is 30 times bigger than the vertical component. So when you square it and find the square root again, it's practically nothing. Questions? Any questions on that one? Do you get what they meant by the components of the final velocity? That is going to be on the test prep that I'm giving you. Okay, I'm gonna post that probably tonight as a PDF, and you can start working on it. Okay, and see, the test is gonna be modeled very, very similarly to the two problems that I'm gonna post. All right, so that's good. Okay, this was chapter 3, number 56, thank you.